Okay. So we're going to go ahead and review. So you guys have the review in front of you. There's no way that I can cover everything on that review in this time. So you guys need to tell me which points on that review you would like me to cover. Okay? So where do you want to start?
Chapter 2.
Significant figures. Okay. And then we'll get to chapter 2.
Can we also
Okay.
the K and the Q?
Yes, we can. Okay. All right. So significant figures. So if I'm looking at significant figures, if I'm given a number and the question is how many significant figures are in this number, okay? So the question I have to ask myself is, why did I write the 0? Why did I write those zeros? Did I have to write them?
No. For some of them.
Okay, if I didn't write them, would that change the number?
Yes.
Yeah, because if I deposit $13,600 into my bank account and they only put 136 in there, right? That's not okay. So why did I write those zeros? Because they maintain the value of the number, right? I have to write them or else it changes the number. So if I have to write zeros, that means that they're there because they have to be, not because they're significant digits. So how many significant digits are in this number? 3. Because these are not significant. They are placeholders. They maintain the value of the number. I have to write them. The only time a 0 is significant is when I write it and I didn't have to. I write it only to tell the reader the type of instrument I used, okay? The measuring device I used. So significant digits, I hate the name significant digit because it confuses everybody, right? So I wish we could change it to a different name, but we can't, all right? So the only reason I write a 0 that's significant is because I didn't have to. So look at these zeros right here. Why did I write those?
Because they're significant.
Exactly. If I take those away, 25.3, 25.3000, those two are exactly the same, right? The value of this number and this number are exactly the same. So why am I wasting my time writing these zeros? They don't change the value of it. They don't help me in the calculation at all. They just waste my time. So why am I writing those? Because they're significant digits. That's the only reason. Okay? So how many significant digits are in this number?
6.
Okay? Are those zeros significant or not?
Significant.
No, the ones you underlined, they're
Yes.
not.
They are not. Why?
Because if you take them
They don't
away,
change
it's a
the
whole
value.
other.
They change the value if I take them away. So did I have to write them?
Yes.
Yes. Right? Because if I take them away, what happens to this number?
It turns to 0.15. Oh, you're talking about that.
That's you're talking about the one.
Sorry guys, these ones right here. Okay? If I take these zeros away, do they change this number?
It's 0.15.
Yes.
Yes.
So do I have to write them?
Yes.
Yes. Are they significant? No.
But the 0 in front is so they're really significant.
This one is not significant. Don't ever worry about that one. Never, 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 never.
There would only be
Okay?
2.
So there are 2 here.
So for the significant figures, you do count the zeros or you don't? I'm so confused.
Yes and yes. Okay? You do count them if they have no value. You don't count them if they do have value. So I wrote these zeros because I have to maintain the value of the number, because if I take them away, it changes the value, right? So those zeros are there as placeholders. They are not there because they're significant. These zeros don't change anything about the number.
So significant zeros don't change anything.
They don't. They're worthless.
What does
Yep.
significant mean? Like you're there for a reason? Like
Good. That's a good question. Why is it there if it has no value, or if it's not really, if it's not a valuable zero? Why did I write it? Okay, that's what you should be asking yourself. Why the heck am I spending my time writing that number when it has absolutely no value to it? The only reason is because when I made a measurement in the laboratory, let's say this was a scale measurement. The scale measures to 1, 2, 3, 4 decimal places. So whatever I weighed on the scale weighed 25.3000 grams. The only reason I write these zeros is to tell the reader that the measuring device I use, the scale I use to collect this, measures out to this many significant digits. Okay? So that the reader knows I used a very precise instrument. That is the only reason we use significant digits at all, is to show the reader the precision of the instrument that we used. This instrument is more precise than this instrument. A 25.3 means, oh, that's not a very precise scale you used to measure that. But a 25.3000 scale, that's very precise. Okay? So they have more confidence. They have more confidence in this 25.3000 than they do in 25.3. Okay? So that's the whole basis behind significant figures. Are these zeros significant?
No. There's several.
Are they placeholders?
yes.
Yes. So are they significant? No. So if they are placeholders, they change the value of the number, right? Look at this number change. Look how much this number changes. 0.00 to, yeah, if I deposited 0.00 in my bank account and it went to that, I'd be very happy, right? Okay? But it doesn't. These are placeholders. They maintain the value of the number. So are they showing the precision of the scale? No. This is showing the precision of the scale. 1, 2, 3, 4, 5, 6, 7. There are 7 significant digits. Because these zeros, if I take them away, they don't change the value. These are not placeholders. They are worthless zeros. So why did I write them? Simply to show the precision of the instrument I used. Okay?
So how come you said on the first one, the last two zeros are not significant? Because there's no decimal.
Good. There's no decimal there. Because if I take those away, it changes the value, right? So I have to write those to maintain the value. So they are not significant. And that's because there's no decimal there. Okay? So that is not, those are not all trailing zeros here are significant, but trailing zeros here are not. Because there's no decimal.
Can you do one more? Just one hard one? Yeah.
Just one hard one?
Let us try to figure it out.
Right? You want that money on the desk.
Let me think. A really hard one, huh?
Just kind of.
Well, I can't.
Yeah, do the one that's on the test.
Yeah, that one.
I haven't. Was there? I don't even remember which. I'm sure I could assume these ones were on the test. Okay, how about with these ones? I mean, to me, it's I can't really think of like what's the hardest one because they all seem so easy to me. So, this,
The first two are 5.
the,
The second one and the last one is 5. Right? 5, 5, 2? Yes.
Yeah, 5, 5. No, the last thing is right.
Okay, so what are you guys coming up with for this one? So these are significant zeros? Yes, they are significant. Okay, what are you coming up with for this one? So are these zeros significant? No. 5. Sorry to be so dramatic. Okay, so there's just 5 there, right? Because they are not significant, they're just placeholders. Okay, are these zeros significant? They are not significant. So it's 2. Say, sandwich zeros are always significant. Okay, if they're sandwiched, they're always significant. So if I put 3 here, now I have 8 significant digits. Okay, because those zeros now become significant.
Mr. Craig, are you like done explaining this?
Yes.
Okay. We can ask questions without you.
Yeah. Well, in a second, I was going to go here to chapter 2, and then I'm going to go to equilibrium or something. Yeah.
Yeah, I just need to know how to do calculations with this thing.
Okay, we'll get there. Okay, so chapter 3, chapter 2, chapter 2. Okay, so let me ask you this: if I have these 3 phosphorus atoms, okay, first question, what is the same about all 3 of these? What's the same? The protons. How many protons does phosphorus have? How many? 15. Good. It's number of protons, electrons, in an atom. Okay, so that's what's the same about them. What's different about them? The electrons are the same. What's different? The mass is different. And what is causing the mass to be different? The number of neutrons. So how many neutrons are in this one? 15. How many neutrons are in this one? 16. How many here? 17. Okay? So the mass of an element comes from the number of protons plus the number of neutrons. Okay? So if I know the number of protons, I know the number of neutrons. Now, let's say that I was told that these are an abundance of 3%, 95%, and 2%. Okay? So these are the percent abundances of each of these isotopes in this molecule. I want to determine the average atomic mass, which is a weighted average, just like you would calculate a grade, which you guys never do anymore because Canvas does it for you, right? Everything for you. Okay, I remember the days. You guys are so spoiled. Okay, so how am I going to calculate the average atomic mass here? I'm going to make a chart. Mass, percent, okay? So the mass of the first one is 30, 31, and 32. Those are the masses of the 3 different isotopes. Their percent abundances are 3, 95, and 2. Now, whenever I multiply something by percent, I don't leave it as percent. I change it to its decimal. What is the decimal of 2%? What is the decimal of 95%? Okay, so I divide it by 100. That's going to change it to its decimal. Okay, so that's what I'm going to do here. Now, I'm going to take 30 times 0.03. What do I find? .9. Okay. 31 times 0.95. and 32 times 0.02.
0.64.
Okay, now I'm going to take these and I'm going to add them all together. What is my average atomic mass?
30.99.
What is it?
30.18.
No. What was it?
99.
Right. Okay, so which matches pretty closely, what are we, phosphorus, 30.97, okay, pretty close. So that's our average atomic mass. That's how we're going to calculate an average atomic mass. Okay. Okay, so you can look at the electromagnetic spectrum to kind of identify radio, micro, infrared. Okay, you're not going to have a lot of questions about that. It's not a big part of the test. Okay, wave properties. If I have this wave versus this wave, okay, my wavelength is calculated from here to here or from here to here. Okay, that's my wavelength. Waves travel at the exact same speed. This one travels at the same speed as this one. What speed do light waves travel at? The speed of light. That's how fast they go. Okay? So, light travels at the speed of light. So these are traveling all at the same speed. But which one has a higher frequency? Meaning, which one will penetrate this point more often per second? The smaller one. That means this has a higher frequency. This one has a lower frequency. This one has higher energy because it has a higher frequency. Okay? The smaller the wavelength, the smaller, the higher the frequency, the higher the energy. Okay? The bigger the wavelength, the lower the energy. So radio waves have very low energy. So we broadcast them all over the place. Okay? We don't care. So those are the basic properties of waves. Okay? Alkali metals, where are they? First column, 1A. Alkaline earth metals, 2A. Halogens, these ones right here. Noble gases, right there. Okay? So those are some of the families of the periodic table. Why do I call them a family? Why are these guys a family? I heard a lot of stuff, and I don't even know what I heard. What is it? The same. Okay, I think I heard it somewhere in the mix there. The same number of valence electrons, right? They all have the same number of valence electrons. Therefore, they have similar chemical reactivities, so they are a family. Okay, so that's why. How do I predict valence electrons? How many valence electrons do these guys have? These guys. These guys. Skip the transition metals, right? They're valence electrons. You can't predict them from the periodic table. Okay? So valence electrons are only counted as S and P. How many valence? 3.
4, 5, 6, 7, 8.
Okay? That's how I know how many valence electrons. Why do I care to know how many valence electrons are on an element? Because if I'm going to predict an ion, I need to know the valence electrons. What is the ion of calcium? Well, look at how many valence electrons does calcium have? Number 20. Remember, it's in the second column. 2 valence electrons. It will lose both of those valence electrons and become what? Become like argon. calcium 2 plus. Okay? So, calcium 2 plus, because it lost 2 electrons. What does sulfur become? It's going to become S2 minus because it has 6, it wants 8. It's going to gain 2. So sulfur is also going to become like who? Argon. Calcium is going to become like argon. Phosphorus is going to become like potassium is going to become like. That's where they're going to get to. That's how I predict the ion I'm going to become as to whether I lose electrons to become like the noble gas or I gain electrons to become like the noble gas. That's called isoelectric. S2 minus, calcium 2 plus, these guys are isoelectric. Argon is also isoelectric with those. That means they have the same electron configuration. What is an electron configuration? How do I write an electron configuration? Let's write the electron configuration of calcium 2 plus. Where do I start if I'm going to write an electron configuration? 1s. Now where? 2s. 2p. 2p. Not yet. It would be 2p6, but then where do I go after that? 3s. 3p6. Now, why don't I go to the 4s?
Because you're going to argon
Because it's an ion. You know the most highly missed question on my tests? What is the electron configuration of the sodium ion? It's not that tricky, guys. Sodium ion. Neon. The electron configuration of the sodium ion is the same as that of neon. Okay? So, don't miss that question, please. Don't ever miss that question again. Okay? It's not 3s1. It's 2p6. Okay?
Sodium would be argon?
Sodium would not go to argon, it would go to neon because it loses an electron. It's a metal. Metals lose electrons. Okay? Okay, why else do I want to know how to predict charges of metals or nonmetals? Because I want to be able to make formulas. Calcium, 2 plus. S, 2 minus. They're going to come together as calcium sulfide. So if I said, what is the formula for calcium sulfide? You would have to say Ca2 plus, S2 minus, CaS. If I said, what is the formula for magnesium phosphide? What is it? What's the formula for magnesium phosphide? Mg2 plus, P3 minus. What's the formula? Okay, I need 3 magnesiums and 2 phosphorus. Mg3P2. That's the formula of magnesium phosphide. Okay, so that's the other reason I need to be able to predict the charges from the periodic table. Okay, valence electrons help me predict those charges for this reason. Now, if I'm naming something, okay, what is the name of that first compound? What is it? Okay, now this is a huge confusion for people, so let me clarify. ATE ions are what? Ate or ite means polyatomic. Okay? So nitrate is NO3. Phosphate is PO4. Sulfate is SO4. 2 minus, 2 minus, minus. Okay? That's what ATE, ate or ite means. So this isn't an ate, it's a what? It's not an ite, it's a ide. It's not a nothing either. It's an ide. So how do I name this? Sodium nitride. Sodium nitride. Why is this not trisodium mononitride? Because it's ionic. Exactly. Ionic compounds are named differently than covalent compounds. Ionic compounds are named without prefixes because I can determine the formula from the charges. You don't have to tell me how many I have. But in a covalent compound, you have to tell me how much there is of everything, okay, in order for me to know what the formula is. So covalent is named different than ionic. Ionic, no prefixes. Covalent, use prefixes. So how am I going to name this one? Phosphorus chloride, phosphorus trichloride, which one? And why? Trichloride, why? It's covalent. Phosphorus.
Covalent was metal with metal, right? I'm sorry, metal with non-metal?
Okay, look at phosphorus and chlorine. They're on the same side of the periodic table. They're both nonmetals, therefore this is covalent. Anytime you have anything of these that are combining together, they are covalent. Hydrogen included. Hydrogen is covalent. Okay? Well, first, is this ionic or covalent?
It's covalent. Wait,
Is Al a metal or a non-metal? It's a metal. Ionic or covalent? No. This is ionic. Metal, non-metal. You see this red line? That's the division. Non-metals, metals. Lead. It's in the P block, but it is a metal. Tin is a metal, right? Al is a metal. What is the charge of this metal? 3 plus. Al 3 plus. Okay? It does not gain electrons, it loses electrons. It is Al 3 plus. Okay? What is the name of this compound? What is it? I think you got it right. Okay. Okay, that's it. That's all I have to do. I do not have to say prefixes. I just have to state what the elements are, because if you tell me the elements, I can determine the formula from the charges. Al3 plus, O2 minus. I get the formula Al2O3. Right? So you do not have to tell me what the number of elements are. You just simply have to tell me the names of the elements. Now this one's a little different. Same concept, little different. Yes? Well, the metalloids are they're the transition here. Okay? So they kind of have both properties. They can kind of be covalent and ionic. What's the name of this? I'm going to add another one here. Iron So first question, is it ionic or covalent?
It's ionic.
It's ionic. It starts with the metal. It's ionic, right?
But you can predict.
Wait, what? No? Okay. So this is ionic, right? So do I use prefixes?
No.
Di-iron trioxide? No. Do you think di-iron trioxide will be an answer choice?
Yes.
Do you choose that one? No. Don't choose that one. Okay? So, which one do I choose? Iron oxide might be an answer choice. That's almost correct. Iron 3. You guys got it back there. Okay? So, I heard Keith say it a long time ago. Good job. Okay? So, iron 3 oxide. Why is this iron 3 and not iron 2? Because of switchy thingy. Okay, good. Okay? That's right. This is iron 3 plus. Okay? What about this one?
Iron 4. Iron 3.
There we go. Why isn't switchy thing working? Because there's no subscripts. So when I have two subscripts, it works. When I don't have subscripts, you need to be careful. It might work, but it might not, so don't trust it. Just figure out the charges. What is the charge of an oxygen? -2. What's the charge of this iron then? So this is iron 2 oxide. Right? Iron 2 oxide. So when it's a transition metal, I need to use the parentheses, Roman numeral, to tell me which iron I'm talking about. Because I have iron 1, I have iron 2, I have iron 3. I have manganese 3, I have manganese 4, I have manganese 2. You have to tell me which one. So, yes?
Is it iron 2 from the charge of the oxygen or from the charge of the
Charge. The iron is iron 2 because the iron has a 2 positive charge. I determined that though because of this charge. That's how I found it. Oxygen has a -2 charge, so this must have a +2 charge. Okay?
So if oxygen was to have like -4, would it have a -4?
If oxygen had a -4, then this would have to have a +4 because it's 1-to-1. Okay? All right. What is this? It is definitely whoops, that's weird. Manganese oxide, but not 2. 4. So, switchy thing does not work. One subscript, don't trust it. What's the charge of an oxygen? There's 2 of them, so that's -4, right? So what's the charge on the manganese to balance -4 charges? +4. Manganese 4 oxide. Okay? Manganese 4. Okay. All right. Enough with naming. You guys are on your own now. Okay. Yes. Okay, I have 2 oxygens. Each one has a -2 charge, so that's -4 charges from oxygen. So to balance that, I have to have a +4 on the manganese. Okay? Okay, so we're going from there to equilibrium, right? Okay, so equilibrium. Let me first say something about rate. Okay? Rate equals the rate constant times the concentration of the reactants. Okay? So if I have this equation, x plus y, let's say y2, produces chapter 7. Okay, so let's say I have this equation. I want to find the rate of this equation. So I balance it, right? And here's my rate expression. How do I finish it?
That's when you put like that over that on top of that
Fraction.
Okay, that's equilibrium. Let's just focus on rate first.
You just plug in the level.
So what I'm asking is, what are the orders?
Oh, it doesn't have an order because it doesn't say rate.
Okay, did they tell me the orders? No. Do I use the coefficients as the orders? No. I do not use the coefficients in rate for the orders. When do I use the coefficients? In equilibrium. Okay? This is the rate. Rate is only affected by the products, or sorry, the reactants, by the reactants, because I haven't even formed this. So I'm just going one way. What is the rate of this reaction? So this is what's affecting the rate. So rate is equal to my rate constant times the concentration of X and Y raised to the orders of N and M. Okay? I don't know what those orders are because they didn't tell me. They have to tell me. If they tell me Y is third order, then I can put a 3 here and cube it. But if they don't tell me, then I leave it alone. You simply have to identify the correct rate expression.
What wouldn't it, okay, just so like I have it in mind, wouldn't it be x2 and y2 though? Not just x and y?
Oh, yes, that's true. Okay. Okay, now, how do I write the equilibrium expression? KQ is equal to
x2 and the bracket thing, x2y, and then the 2s, and then the 2 on top.
then I have to raise it to their orders, right?
And then square on the x.
Okay, so this is the correct equilibrium expression. That's how I'm going to write my rate expressions and how I'm going to write my equilibrium expressions. You do not have to know how to calculate rates. You do have to know how to calculate equilibriums. Okay? Because I could definitely give you concentrations that you would substitute into this. The very first step is to be able to identify what the correct equation is to calculate the rate, the equilibrium constant. Yes?
How do you know which one goes on top?
Great. So KQ is always products over reactants. So my products always go on top and my reactants always go on the bottom. You want me to give you numbers? Okay, if I tell you at equilibrium, these are the concentrations, what is the KEQ? So I'm going to substitute for y to x to y, 0.63 squared divided by 0.02 squared times 0.015. Okay? Now, whenever I see you guys doing this, this is how I see a lot of you enter it into your calculator. Okay? I see you go 0.63 squared divided by 0.02 squared times 0.015. Guess what? That is incorrect. Your calculator will not give you the correct answer if you put it in like this. Because this is what your calculator thinks you're telling it. It thinks you're telling it 0.63 squared divided by 0.02 squared times 0.015. Is that what you're trying to do?
Even if you
No. this is not what you're trying to do. Okay? If you put it in parentheses, fine. Now it understands. But if you didn't do that, this is what it thinks you're doing. Okay? So either put it in parentheses, that bottom part, or you can enter it like this. 0.63 squared divided by 0.02 squared divided by 0.015. Then it understands. Oh, I'm dividing by this, and I'm dividing this whole term after I calculate it by this as well. Okay? So this will give you the correct answer, and this will give you the correct answer, but this will not. That will not give you the correct answer. So, what is the correct answer for this? Say it loud.
66,150.
Oh, I got that one. I was supposed to do it.
Okay, so this is my KEQ for this reaction. What is the KEQ telling me? Do I have more product or reactant? If I have a large KEQ, that means I have mostly what? Product. Because the top number is bigger than the bottom numbers. The product's number on top. Okay? Which is definitely the case here, right? This is definitely bigger than these. Okay? So I should have a big KQ.
So how are, what is the whole NH3 equilibrium that I saw that on these two? Is that just like a regular equation, or is that the formula? That's what I don't understand.
Isn't it the same thing as like the Epsilon?
Is that what it is?
Yeah.
Okay.
Yeah.
Just using different.
Same thing here. So this is, I have a balanced chemical equation. This is my balanced chemical equation. What is the KQ for this? NH3 on top, because that's my product. Square it. Divided by concentration of N2. No, yeah. Some of you chose plus. Don't add it. Times H2 cubed. This is my equilibrium expression, my equilibrium constant equation for this reaction.
Can you go over how
Okay.
to predict if the reaction is spontaneous or not according to G?
Okay, so if you look at that chart on the on number 9 for chapter 7, okay, that chart very simply is saying, what is delta G? Well, if you're given delta H and delta S, it's easy to predict. If delta H and delta S have opposite signs, then delta G takes the sign of delta H. What is the sign of delta G here? Takes the sign of delta H. What is the sign of delta G here? Negative. If the signs are the same, delta G is temperature dependent. That's it. That's all you have to know.
So we don't have to like solve anything, we just write that?
That's it. That's all you have to know.
I was thinking it was going to be on the.
Can you like give us this on the test?
Well, maybe it wasn't for you.
Oh, that's right. What is delta G?
Delta G is the Gibbs free energy. It's determining whether your reaction is spontaneous or non-spontaneous. So delta G negative means that it's spontaneous. Delta G positive means it's non-spontaneous.
Is delta G free energy?
Free energy. It's the free energy of the system. That's exactly what it is.
You said this positive is non-spontaneous?
Yes, that's exactly right. Delta G positive is a non-spontaneous. Delta G negative is spontaneous.
Remember chapter 8?
Well, this part.
Okay, let's look at our pH diamond. Okay? So, let's say I tell you you have a 0.0185 molar solution of HClO3. HClO4. Let's do that one. Okay? What is the OH minus ion concentration?
1 times 10 to the -4.
So, how am I going to answer this question?
The -4.
What information do I need?
H plus.
I need H plus. I need to know the H plus ion concentration so I can get to the OH minus. Does this tell me the H plus ion concentration? What? Yes, it does. What is the H plus ion concentration? It's 0.0185 molar H plus. Why? Well, this is a strong acid. It dissociates into these two ions, producing H plus and ClO3 minus in solution. And it dissociates 100%. It's a strong acid. How do you know it's a strong acid? Because I would never give you a weak acid and ask you to find any of this. That's how you know. If I give this to you, it's either a strong acid or a strong base. Okay?
And so what do the acids have to be?
ClO4. What's that? So if it's a strong acid, it tells me the H plus. If it's a strong base, it tells me the OH minus. Okay? In this case, this is a strong acid, so therefore it's going to tell me the H plus. I can now calculate the OH minus. Look at H plus on your pH diamond. What is the equation? Look at the arrow pointing to OH minus from H plus. What is the equation I would use to calculate the OH minus from the H plus?
1 times 10 to the -14.
Divided by
OH.
H plus. I don't have OH. I'm getting OH. Divide. So look at the arrow, the one that's pointing to the OH from the H plus. Do you see it? Use that equation. 1 times 10 to the -14 divided by the H plus ion is going to give you the OH minus.
Are we gonna have this little chart?
You are. Okay? This is your reference. That's why I put it on here so you guys could learn how to use it. Yes? It depends on where you're going. If you're going from OH to H plus, you're going to use the inside. If you're going from H plus to OH, look at the arrow. Do you see the arrow which way it's pointing?
OH is 5.4.
If the whatever way the arrow is pointing, that's the way you're following. Use the equation associated with that arrow.
So it always tells you like what you have. Like it's gonna say like your pOH is blah blah blah, and you have to do it from there.
Yeah. So if you have a pH equal to 3.75, what is the OH minus ion concentration?
10 to the negative. Is that a negative?
Okay, so look at your pH diamond. If I'm going to go to OH minus, I have two pathways. And it doesn't matter which way you go, you'll get the exact same answer. So I can either go from pH to my H plus, then to my OH minus, or I can go from pH to POH to OH minus. It doesn't matter which way you go. Let's go from pH to POH.
Wait, which one are we doing now?
This one.
So you don't want the answer to the other?
What is it?
5.41 times 10 to the negative 13.
Okay. All right, so my POH, if I have a pH of 3.75, how do I find my POH? What is your diamond telling you? 14 minus the pH is going to give me the POH. What is the POH? 10.25. Okay? What is, now from the POH, I can find the OH minus. What equation am I going to use to go from POH to OH minus?
10 to the negative 10.
The anti-log. Exactly. 10 to the negative 10.25 equals what? Using the anti-log, what is it?
1.78 times 10 to the 10. Just regular 10, no negative.
That can't be right. Say it again. 10 to the what? Negative 11. Okay, there we go.
So it's negative.
10 to the negative 10.25. That's how you got a huge number instead of a small one.
I got 5.62. It's not 5.16, it's 5.62.
To negative 11.
To the negative.
You got a question?
Yeah, I wanted to see how you put it in the calculator.
Okay, do you see the LOG? Do you see the LOG button? Do the shift function of LOG, log, and then enter negative 10.25.
So this is what we needed to do on our test today.
Maybe. Was there? Did you get a pH question?
Yeah, and I had no idea how to do this. That's why I got the book wrong. I know. That's why I got the graded difference. I passed.
Okay.
I mean, it was just this question.
Is the
Okay.
negative- Sorry, is the negative log right here always, is that anti-log or is that,
When it says 10 to the negative POH, that's the anti-log.
and what's the negative LOG?
That's the negative log of H plus. That's going the other way. Okay, so I found the OH minus. All right, that's one way I could have done it. I could have gone the other way, and it would have been the same answer. I would get this same answer. Okay. Okay, so that's how you do that. You want to do one more?
Yes.
Okay. Let's say your H plus ion concentration is equal to 7.56 times 10 to the negative 4. Okay. What is your POH equal to? What's the first step? Which way do you guys want to go?
pH.
Okay. So what's your pH here?
Negative loss.
I need to take the negative log of 7.56 times 10 negative 4, and that's going to be my pH. So in your calculator, you'd hit the log button and type 7.56 times 10 negative 4, and it's going to give you a negative number. You drop the negative,
3.12.
and your pH is 3.12.
So you don't put negative log, just put
Go ahead and put negative log if you want.
So, like, if we get a negative answer to this, we're supposed to drop it in the bottom?
You always drop it, because these are always positive answers. The pH would never be a negative number. You'll calculate a negative number, and then you drop it because it's the negative of that negative number.
10.88.
Huh? A negative times a negative is a positive. So it's always a positive. This always calculates out to a negative log, and you drop the negative because you times it by a negative, and so it's a positive. Okay. Yes. Okay, so hit your log button,
Okay.
and then type 7.56 times 10 to the negative 4.
Oh, you put it.
What is it? Okay. And then my POH is what? You always drop the negative. It's never a negative answer, because you calculate the negative, but you take the negative of the negative, so it's a positive. Okay? All right, now, conjugate acid, conjugate base. All right? So if you have H2PO4 minus. So if I ask you, what is the conjugate acid of H2PO4? Okay, if I ask you what the acid is of this, you always add a hydrogen to make it the acid. So what is it if I add a hydrogen? So this is the conjugate acid of this base. What is the conjugate base of H2PO4? HPO4 2 minus is the conjugate base of this acid. Okay? So if I ask you for the base, you remove a hydrogen. If I ask you for the acid, you add a hydrogen.
How come you have a 2 minus? Like up there? Is it because it's like H2 on the original one? Or why you put a 2 minus?
Every time you remove a hydrogen, it becomes more negatively charged because hydrogens are positively charged. So if you remove a positive charge, you're going to become more and more negatively charged.
Okay.
So what is the conjugate base of HSO4 minus? What's the base?
SO4 minus 2.
Yeah. What is the acid? The acid always has more hydrogens. The base always has less hydrogens. Okay? This is the conjugate base of this. This is the conjugate acid of this.
What's the conjugate base of the acid?
There isn't one. That's as far as it goes, right? There's no more hydrogens. You're done. So, what is the conjugate base of HPO4 2 minus? Phosphate. Phosphate. That's as far as you go, right? Phosphate has 3 negative charges, therefore it can have 3 hydrogens. Sulfate has 2 negative charges, therefore it can have 2 hydrogens. Yes?
Could we go over the oxidizing base?
Okay. Okay, let's say you have this equation. Magnesium plus oxygen produces magnesium oxide. What is the oxidizing agent? Okay, so let's start here. What is oxidized? Oxidation is loss. Reduction is gain. So what is oxidized? Okay, magnesium went from a 0 charge, oxygen went from a 0 charge. Magnesium's charge over here is what? Look at the periodic table. What does magnesium come to? 2 plus. Thank you. Oxygen? 2 minus. So who gained electrons? Who gained electrons? Oxygen gained electrons. If you gain electrons, that means you're what? Yes, you're negatively charged. So are you oxidized or reduced? Reduced. Reduction is gain. Reduction is gain of electrons. What is oxidized?
Magnesium.
Magnesium was oxidized. So now that I know what was reduced and what was oxidized, I can identify the oxidizing and reducing agents. What is the oxidizing agent? Oxygen is the oxidizing agent. What is the reducing agent?
So you just like flip this.
That's what you do. It's exactly what you do. Okay? Okay? What is oxidized? What is reduced?
Do the charges always start with zero?
If they are by themselves. The only reason they're starting out 0 is because they're by themselves.
-2 is C.
So if they're not by themselves, then you have to figure it out like you're doing over here. Okay, to figure out if they switch. Ca is what? It loses electrons, becomes what? 2 plus. Cl is what? Negative 1. Okay? So, calcium comes here, becomes Ca2 plus. Was that oxidation or reduction? Oxidation. Oxidation is loss. Reduction is gain. So, what is the oxidizing agent? What is the reducing agent? Okay. So that's oxidation reduction. That's how we would look at that. One more thing. Pick something really hard.
There's a lot of questions on these. It's all hard.
If you have 27.5 grams of H2, how many grams of water are produced? Stoichiometry. What's that? Okay, that's your first step. 27.5 grams. I cannot, so here I want to change it from hydrogen to water. That means I have to do stoichiometry. The only way you can change between two things is if you're doing stoichiometry. Okay? So, the only way I can perform stoichiometry is if it's in moles. I can't perform stoichiometry in grams. So I'm going to change this from grams of hydrogen to the moles of hydrogen first. Okay? Now, I can change it to the moles of H2O because it's in the moles of oxygen. But to answer the question, I need to finally change it to the grams of H2O because they don't want the moles of H2O, they want the grams of H2O. Drop your units. Okay? Grams and moles. Moles are always 1.
And 2 grams
For hydrogen, 2 grams for every 1 mole. That's how much it weighs per mole. Water weighs 18 grams per mole. 1 oxygen, 2 hydrogens. That's 16 plus 2. That's 18. What's the relationship here in the middle?
2.
Yes. So I have 2 hydrogens for every 2 waters. So 27.5 times 2 times 18 divided by 2 divided by 2.
247.5.
Okay, this is also called a theoretical yield. So if I had produced 230 grams of water in the laboratory, how would I find a percent yield? Actual over theoretical times 100. 230 divided by 247.5 times 100. Okay? Theoretical yields are calculated yields.
Hold on, where did you get the 230?
I made it up.
Oh.
I just said if I actually, so I was just pulling out my head. If I went in the laboratory and I made 230, they have to give you that in the question. They have to say you produced 230 grams. What's the percent yield? You would calculate the theoretical, and then you'd be able to find the percent yield.
Okay.